Crafton Hills College in Ukiah, California. I'd like to thank the HTCC and UC Irvine for the opportunity to speak here today, as well as Professors Gary Williams, Tom Crane, Richard Hughes, and Ted Phillips for their guidance in getting here today. As a trained machinist, I spent many years working metals like steel, aluminum, and titanium. Catching gold fever from my father, I spent a lot of time digging for that precious metal. Those that know me, it's no surprise that I decided to become a mining engineer. Add to that a deep interest in space and space technology, and it's not a far leap in my head to mining asteroids. But I go one step further and I ask, is mining asteroids unavoidable, considering the long-term sustainability of mineral resources for a growing, technologically dependent society? So to answer this question, we will move backwards through my title. My first point will be modern society that is dependent upon technology. My second point will be the growing population that is dependent upon technology. My third point will be the metals used in technology. My fourth point will be the metal reserves and estimate for how long they will last. My fifth point will be space technology and asteroids. So we'll begin with my first point, technologically dependent society. Electricity powers our technology. These pictures are from space. You can see how much of the Earth we're actually taking up and lighting up with our own energy. Modern society has been built on technology. From cell phone technology that communicates us in every aspect of our life, utilizing satellites and as well as ground-based systems to get those signals from person to person. Technologies like farms, they use this so they can grow massive crops that can feed our cities. Transportation technology gets this food from the farms to our cities where you can go and get it from the grocery store. Life-saving medical technologies, MRIs, X-rays. We can take parts of one person and put it into another person. This is all due to technological advance that our society has built itself upon. Modern society makes the best use of technology to make life better, more productive, hopefully have more fun, and live longer. This brings me to my third point. Second point, the growing population that is dependent upon technology. The population of the planet has grown drastically. In 1950, it was around 2.2 billion people. By 1980, it was up to 4.4. Today, it stands a little over 7 billion people, and the low side projections for 2050 are over 9 billion people. That is almost a quadruple in our population within 100 years. Some countries are experiencing rapid growth, much rapid growth compared to others. Nations known as the BRIC, Brazil, Russia, India, and China. They're having a large growth in population as well as a large expansion in the middle class. China last year surpassed the United States population with their number of drivers. They have over 300 million drivers registered. Almost 10% of those drivers are new drivers in 2014. That's almost 30 million new drivers. It's a lot of new cars, a lot of new technology people are starting to use. Cell phone sales have gone through the roof. In 1997, there were a little over 1 million cell phones sold annually. By 2005, that raised up over 800 million units sold annually. That is a 1 million unit rise every year. And these things use a whole lot of materials. There'll be a lot of people that are going to rely on these benefits of technology in the coming years. That's going to take a lot of resources, which brings me to my next point. The metals in technology. A cell phone by weight is about 25% metal. This is a list of all the metals that can be recovered from cell phone recycling. These metals have uses in all aspects of our technology, not just cell phones. Copper used in electronics heavily. It's also used in piping for water. Many of these elements are added to steel to give it different properties that we take advantage of. Our energy generation technology is a technology in its own, and it's also highly dependent upon metals. Solar panels use small amounts to help transfer electrons, which give us our solar energy. Just about any kind of power generation does the same thing. It spins an electrical generator, whether it's wind, water, coal, or nuclear power. They're going to be making electricity for people to use. Stainless steel, metal technology, is a technology in itself. Where would we be without the stainless steel that's in our kitchens, that's in our hospitals, that helps us get by from day to day just by being there? There's the metals that hold up our structure, our infrastructure, our pipes. They get our water and sewage to us, our gas, our utilities. Metals affect every aspect of our life. If a product doesn't contain metals, it was either made by a machine with metal or transported by something with metal. Our technology and the large number of people using our technology has put a drastic strain on our metal resources. The metal reserves that we have are not projected to last too much longer. The banded iron formations, which much of the world gets its iron, took millions of years to form. In my research, I came across this report from 3 Japanese scientists entitled Forecasting the Consumptions of Metals up to 2050. Many other reports that I found, like the one listed below, Life of Resource Sustainability Considerations for Mining in the Australian Journals of Civil Engineering, they talk about how there's a big transition from high quality ores over to low quality ores. And they talk about how it's going to continue, and they're going to have to keep looking for more metals, but no one ever put a date on it. This was one of the first reports I found that actually put a date on how long do we have until these metals run out. And some of the dates that they put on here were kind of scary. By 2050, we're expected to be consuming 5 times the amount of iron that they were in 2008. This is going to put a drastic strain on our reserves. We have 2 types of reserves. We have what's called the current reserve and what's called the base reserve. The current reserve is the reserves which we can extract right now economically. There's enough money being paid for it that they can mine the material, sell it, and still make some money. The reserve base is the estimated amount of material available that can be technically extracted, regardless of economics. As prices of metals go up, it becomes more profitable to mine. It becomes profitable to mine more expensive, harder to obtain metals. This in turn increases our current reserve, so we're not really losing a lot of what we can actually get, but we're getting closer and closer to that base reserve, of which there is no more after. They predicted that by 2050, iron, aluminum, chromium, and cobalt will exceed our current reserves. But more importantly, indium, silver, zinc, lead, gold, copper, nickel, and platinum will likely exceed the reserve base. The authors expect there's going to be some heavy transitioning to alternatives. But some metals we cannot use an alternative. It is the only one that will do the job. As metal prices rise, lower quality metals that are more expensive to attain and refine become more profitable to mine. When there is no lower quality material available, where do we go? Is mining asteroids unavoidable? Space, technology, and asteroids. The International Space Station launched in 1998, and it's been in orbit ever since. Yesterday, 2 astronauts, one from America, one from Russia, left to spend a year on the space station. We have several robotic rovers on Mars. 2005, a NASA probe Cassini flew in between some of Saturn's rings and launched a probe onto one of its moons, Titan. The same year, the Deep Impact mission met with Comet Tempel 1 and slammed an impactor into that comet, giving us valuable information about the composition of asteroids and comets. The Stardust mission launched in 1999 It met up with comet Wild 2 in 2004, and then in 2006, it returned particles of that comet to Earth for study, again giving us valuable knowledge as to what's out there in space. Last year, the European Space Agency put a lander on a comet. You might have heard of the Rosetta mission. It is on the comet, sticking with it, giving us daily updates as to what's coming out of it. All kinds of new information is being learned on these missions. NASA is currently building the Orion space capsule. It is the successor to the shuttle. The shuttle was never designed to leave low Earth orbit. It was only designed to go up and handle satellites. The new series will extend our missions beyond the restraints of our orbit. They have planned missions to Mars, manned missions to Mars and to asteroids in the next 20 years. One platinum-rich asteroid can contain as much platinum as has ever been mined in the world. This comes from planetaryresources.com. Planetaryresources.com is backed by the company Planetary Resources, which in 2012 declared their intention to mine asteroids for their mineral resources. In just 10 days from now, they will be launching their second asteroid prospecting satellite, which will not be tethered to Earth and will be able to more accurately distinguish the different types of asteroids and which ones would be good to go after and mine. This company has a lot of high-profile business and space technology individuals, working with some of NASA's ex-employees as well as NASA themselves. They have a very good timeline and a very good plan as far as going out there and getting what we're going to need. NASA has been tracking near-Earth objects since the late 1990s. To date, there are over 12,000 objects that have been found. Many of these asteroids are right in our neighborhood and are energetically easy to get to as the moon, which we went to over 50 years ago. I explained first about modern society dependence upon technology, about the growing population that is dependent upon technology, the metals used in that technology, the metal reserves and estimates for how long they're going to last, and asteroids and space technology. So I ask one more time, is mining asteroids unavoidable, considering the long-term sustainability of Earth's mineral resources for the growing technologically dependent society? Even if these figures are off, and it takes a lot longer than they say for us to run out of these metals. These banded iron formations took millions of years to form. Our civilization is only thousands of years old, and we're counting our resources in the hundreds of years. Our civilization needs to leave the planet in order to find the resources it needs to continue on into the future. Humans are not dependent upon technology. We will go on with or without it. But life in modern society is better because of technology, made possible by the metal resources and other resources that we have here on planet Earth. By looking ahead, we can plan and prepare and give our civilization a few more thousand years to thrive. Thank you.
Thank you very much, Wes. Let's see, is Anthony Vasquez here? Okay, perfect. He's